So Kepler's laws allow us to determine the speed that a planet moves through its gravitational field, or the speed of rotation around the Sun. So to find the orbit speeds of Mercury and Earth, we need some information that we can look up in the data table. We're trying to find the speed. We will need to use G, 6.67 times 10 to the minus 11 Newton meters squared per kilogram squared. We need the mass, but this is not the mass of the object that is orbiting. So this is not the mass of Mercury. This is the mass of the object that Mercury is orbiting around. So in this case, that's the Sun, and the Sun has a mass of 1.99 times 10 to the 30th kilograms. That is a key thing with Kepler's laws and orbits, is knowing what object is orbiting around. So we are talking about the Sun for the mass here. And the radius is not the radius of the object. It is the radius of the rotational orbit. So Mercury is 5.79 times 10 to the 10th meters from the Sun when it orbits. The equation for orbital speed, V equals square root of gm over r. Substituting in, G 6.67 times 10 to the minus 11, M 1.99 times 10 to the 30th, R 5.79 times 10 to the 10th, we can do that all in one step, and going to 3 sigs we get 47,900. That's the speed, which is measured in meters per second. However, most oftentimes orbital speeds are not referred to in meters per second, they're referred to in kilometers per second. This would be the equivalent of 47.9 kilometers per second. Meaning that Mercury, as it's going around the Sun, moves 47 kilometers every second. Same idea for the Earth. G is always constant. M will continue to be the mass of the Sun, but now we need the orbital radius of the Earth, which is 1.49 times 10 to the 11th meters. Substituting into the equation, I'll go straight ahead to that because we already have it written down. G hasn't changed. M, mass of the Sun, hasn't changed. R is now the orbital radius of the Earth, 1.49 times 10 to the 11th. Again, we can work this all in one step. Going to 3 sig figs, we get 29,800 meters per second, or 29.8 kilometers per second.